Hello everyone, this is the video lecture for Calculus 3, section 15.7, cylindrical coordinates. So, we've seen a lot of these formulas before in pre-calculus and calculus and Cal2 probably, but now we're making it official. We're going from XYZ into R theta Z. So this is cylindrical versus rectangular here. This is rectangular. So a lot of the questions will say, hey, go from rectangular to cylindrical or something kind of like that. Let me give you some formulas that are useful here. We got r squared is equal to x squared plus y squared. We have tangent theta is equal to y over x. We have x is equal to r cosine theta. And we have y is equal to r sine theta. Now, this is all stuff that we've seen before. You could basically classify all this stuff as polar. And so think about it like polar. We're going from x, y, and we're going over to r theta, essentially. So r out with a theta angle. So polar mode is something we're really familiar with. I'm not worried about it. The difference between here and there is z equals z. Notice that this is the same as that. So as soon as we move to 3 dimensions, it's the same kind of idea. You got your r, you got your theta on the xy plane, and then you just go up or down however much z distance that you need. So that would be a z distance up. And so really, it's no different than polar form, but we're just changing that z. So we just have a z in there. That's literally all it is. So I find this actually like a pretty easy system, a good system to use a lot of times, because it's very familiar with us. So 15.7.001, they give us a point 6 pi over 3 negative 2, and they want to graph that. Now they're talking here r theta z. So what does that look like? X, Y, Z. I got a 6 radius. I got a theta, which is pi over 3, 60 degrees essentially. So this is 60 degrees here. Again, this is all on the XY plane. I've moved out a 6 distance, and then I go down 2. So then we would go down 2. And so that's going to be my point. Like if I wanted to rotate it a little bit here, X, Y, Z. Again, we're going to come out this way 60 degrees. That distance there is 6, let's say, and then we go down 2. So there's my point P. You can keep rotating it. It's not that big of a deal, though. I just wanted to show you multiple angles. So here again is 60 degrees, 6 distance, going down 1, 2. So there's my point in 3 different ways of seeing it. Okay. Next one is a conversion. 15.7.004. It says go from rectangular to cylindrical. And so they give us negative 6, 6, 6. And they're wanting to know what is that in r theta z. So then I have r is actually the square root of x squared plus y squared. So the square root of negative 6. This is an x, y, and a z, by the way. Just wanted to remind you. Negative 6 and 6. So really you get square root 72 in the end. 36 plus 36 is 72. So that's good enough. My theta is arctan of y over x. Arctan of negative 1 should be basically negative pi over 4. But here's the thing. That's what I would get from the calculator, essentially. But where is this located? So if you draw a quick little sketch of where the xy coordinate is, negative 6, positive 6y, it's over here in quadrant 2. And so does that negative pi over 4, does that negative 45 degrees make sense? No, it's actually up here at 3 pi over 4, or you could just say 135 degrees. Okay, so that's the one I really want to use. Again, it's best to draw it and see where it is, and that way you know exactly what to see there. And so z equals 6. Obviously, this right here should be the same as this one right here. It's very simple. So putting them all together, we have our answer here. It would be square root 72, 3 pi over 4. My pi's are looking a little bit bad there. And then 6, and we're done. Notice that the parentheses are already given to you, and there's a box on the inside of those. So you're just putting the 3 numbers with commas between them. All right, 15 7 0 09. I got 6 squared minus 9x plus 6y squared plus z squared is equal to 5. And they say convert to cylindrical. Convert to cylindrical. Well, that's a whole mess. Like, what exactly is that shape here? I think it's like an ellipsoid or something kind of like that. I'm not 100% sure, but we need to convert it into r's and thetas and stuff like that. Well, basically, I'm going to go back to the formulas and simply just plug it in. So r cosine theta all squared. Here we got an r cosine theta. Here we got, there we go, plus sign. R sine theta. Z is z, so you don't change that at all, equals 5. Oh, that's a square right there. Okay, so one thing in particular is that I see these two guys are very similar, heck, with the 6 in there even. So what I'm going to do is, and they're both positive also, I'm going to essentially pull out a 6r squared. You see how if I distribute, I would have a square for those. And then I'm left with cosine squared plus sine squared. This guy right here, 9r cosine theta. Nothing changes there much. My r is looking a little weird. Z squared equals 5. This guy is 1. So you can just get rid of that. And I think they stop here. I think they're done. That was not too bad there. Just, converting it so that there's no more x, y's anymore. There's just r's and thetas. That's all they're looking for. Triple integral of x squared plus y squared dv. They say we want to have this integral done inside of the cylinder. X squared plus y squared is equal to 9. And then between the planes of z equals -6 and z equals -2. So that's kind of strange, but I'm going to try to draw it for you. Essentially, x, y, z, we have a cylinder here with a radius of 3, but it's located kind of negatively. It's like way down here and down here. So there's your cylinder. So inside the cylinder, between these planes here that are basically cutting off the cylinder at -6 and -2. So we're wanting to find out, it's not the volume, but we're trying to find out what this integral is. This right here essentially is like a density of some kind. So maybe like we're looking for weight or something. Honestly, I think going to application-wise is a bit, you don't need to do it. Just do the integral and get an answer, you know what I mean? So just what is the integral going to end up being? So what we want to do is convert this rectangular form into cylindrical form. So like I'm needing to rewrite my integral. Notice that we have square root of x squared plus y squared literally is just an r. That's literally just an r. But whenever I convert to cylindrical coordinates, I need to remember my requisites and stuff like that. When we went to polar, if you remember, it was always r, dr, d theta. Similarly here, we're going to have an r, dz, dr, d theta. That r still is there. That's my requisite r, okay? Still need it whenever I go and convert. So this is going to be my new integral, but now I need to find out what my limits are going to be. Notice that dz comes first. I personally like that. I think it's a little easier. We're going to go from -6 to -2. Very simple there. My radius r, if you notice what's my radius is 3, so we're going from 0 out to 3. So from 0 to 3. And then finally, how much like angle are we going? A full 0 to 2 pi. So our integral really is just r squared. But notice that our first integral that we're going to actually be performing is the z. So don't go and integrate the r squared yet. You would actually have r squared z from -6 to -2 dr d theta. Toss those in, and we get then r squared times -2 plus the 6. And so we would get a +4 out of that, essentially. And so +4 is going to come to the front. And now we have our typical polar form right now. And so we were going from 0 to 3 on this guy. So when I integrate, we got r cubed over 3 from 0 to 3. D theta now. The 0 it's going to cancel. The 3, if you plug it in, you got 3 cubed and a 3 in the bottom. So there's actually going to be only 2 3's left over, which makes a 9. And 9 can come to the front with the 4 to make a 36 here in a second. And, of course, there's no thetas or anything, so you can just take that 2 pi and put it down there. Oops, that's a time sign there, not an equal sign. So 36 times 2 pi makes 72 pi, and we are done. So that wasn't too bad. Next one, 15.7.025. So it says, find the volume of the solid enclosed by the cone. Okay, so here was a cone. Z equals square root of x squared plus y squared. And the sphere, and here's the sphere equation, x squared plus y squared plus z squared is equal to 72. Okay, so my radius here would be then r is equal to the square root of 72, if you're wondering. Over here, this is kind of interesting. Consider for a second, if you're going to convert this side to rectangular, you would have z equals r. So that's kind of a strange thing there as well. But what does it even look like? What are we even trying to find here? So we have a cone, and I'm going to tell you this cone is interesting because it goes up at 45 degrees. That's just something that I would suggest you kind of know. What's your slope here? Well, it's a 1-to-1 ratio. 1 z for every 1 r. So however far out you go is however high you go. See, that's a 1-to-1 ratio. Therefore, what's your angle theta for that guy? Would be basically 45 degrees. So we're going to use that later in our integral, I'm sure. So we got this big cone, which I did not draw very well. Let me try again. So I have a cone. Oops, well, close enough. And then we have a sphere. So the sphere, I'll use a different color. Basically, it's just a sphere from the origin. So where are they colliding is there's going to be this circle part right here and part of a dome. There's part of like the sphere dome still in there. And then it's going to come down like this. What you're honestly getting is something that kind of looks like an ice cream cone. Kind of like an ice cream cone. So we're trying to find the volume of the ice cream, the cone, and the ice cream on the top, basically. Okay, so how do we find the volume? It's actually pretty simple. You're going to do, your volume is equal to triple integral of 1 dv. Now, I want to convert this over to, I would say polar, but into cylindrical coordinates. So requisite r, dz, dr, d theta. So this is actually all I'm doing. There's nothing else to put here. There's no density or something like that. It's just simply an r. What I need to do is fill in all my integral limits, though. So I'm going to kind of give myself a little bit of room so I could discuss this stuff. Well, first off, dz. dz comes first. What would be my z? I honestly don't know, so I'm going to just leave them blank for a minute. Over here, I'm now working with my r's. My r is kind of interesting. I know I'm going from 0 to something else. I don't really have a great answer for this right now, though. Like, I'm thinking that my answer is going to be square root 72 or something like that, but I'm not 100%. I'm just a little questioning this because we didn't really go out all the way to the sphere all the time. So let's just kind of hang on to that one for a minute. So I don't know, but 0 for sure is where we're starting. And then I think the theta is going to be easiest, 0 to 2 pi, because we're certainly going all the way around for sure. So that's easy. I need to fill in these other missing gaps, essentially. Let's start with one of the equations that we had already seen. Z equals R, essentially. Okay, so with that in mind, let's see here. We also have... right. Okay, so Z equals R. I'm going over to my other equation now. Let's go over here. It's kind of like you got to do two of them at the same time. Well, we know that x squared plus y squared is r squared, right? And if I get z by itself, I'm going to move the r over. So z squared is equal to 72 minus r squared. Square root both sides. And I'm assuming that this is going to be positive because the cone and the... Actually, you know what? I wonder if there's part in the bottom as well. Oh, no, because it's a positive cone. It's only the top. Okay, yeah, so we can say just positive here as well. That's fine. So it's positive square root 72 minus r squared. Notice that we have this, and we also have this here. And see how my z's are the same? So in a way, I could say that r is equal to the square root of 72 minus r squared, and start to solve. So undo the square root by squaring the other side. Move over this square so that you got a 2 there. Divide by the 2 on both sides, and r squared is equal to 36, which makes r equal to 6. So that's from the equations, that is what I'm given. Now, what does this r equals 6 mean? Well, basically, we have our ice cream cone, right? Cool. But if you had a shadow of where that fell down onto the xy plane down here, you would see this radius here is 6. That's a 6 radius that way. Again, we're not going all the way out to the edge of the sphere here. It's not like... It's just this r is literally just on the xy plane. We're not going up and out. Okay, so keep that in mind. We're only sitting on the xy plane. That's why I'm trying to figure out what's going on just x and y wise. And so now let's go ahead and fill back in my integral here. R dz dr d theta. So 0 to 2 pi for sure. For my r, I now know it's 0 to 6. And my z is kind of interesting. I'm wanting to go basically from my cone up. It's kind of like you're wanting the bottom and the top functions for z, for your dz. Well, notice that this sphere cap is on the top while your cone is on the bottom, right? So I'm going to basically want to say on the bottom we have cone, and on the top we have sphere. That's kind of what I'm wanting to get at. So let's go and try that. See how I'm trying to analyze this, and that's a 2 pi, and see how I can figure out what's going on. Well, if you go back up, these are still z equals. So this was my sphere, and this is my cone. Cone's on the bottom, sphere's on the top. R dz dr d theta. Phew. Okay, this should do it. And so let's figure it out, but it shouldn't be too bad now. In terms of z, there is no z, so you're just tossing these guys down with a subtraction sign between them. Dr d theta. Notice that now, if I distribute this guy, we have over here a u substitution. I don't want to do that. And over here we got a square. Well, the square is super easy. You just cubed over 3. This guy's a u substitution, right? And so du would then be 2, negative 2r, dr, etc. You're going to divide by a negative 2, essentially. So negative 1/2. And you know what? Let's go ahead and just integrate. Hold on. So that's u to the 1/2, and so then that's going to now be to the 3/2 power something kind of like that. Over here we got r cubed over 3. It's pretty easy. From 0 to 6, and d theta. Go ahead and put the 0 to 2 pi in there to make it look good. So the 2's cancel, obviously. The 0 here and the 6 actually give you different kind of numbers, so watch out there. Hold on. Going to my next page here. Yes, everything's good there. So I actually have to plug in. Here the 0 doesn't matter, but plugging in for all that stuff. I got here we go, negative 1/3. First off, 72. Plugging in the 6, so that's 36. So 72 minus 36 is 36. The square root of 36 is 6, and then 6 cubed. 6 cubed real quick. Hold on. 216, yes. So 216. Plugging in the 6 over here, you can see that we're going to have 216 divided by 3 is 72, so minus 72. Okay, so that's all this stuff. Minus, now we're going to plug in the 0. So negative 1/3. And then we got 72 minus 0 is 72. I don't really know how to describe that right now. Just 72 to the 3/2 is fine. And then, of course, we get a 0 there. Didn't really do that right there. D theta. Well, of course, there's no sines or cosines or nothing, so you're just going to toss the 2 pi in the front. When you do the math here, this is a 72 as well. And these guys combine. 2 negatives here will make a positive. So blah, 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 math. And then, of course, that 2 pi comes to the front. I got 144 square root 2 minus 144. So these guys here did that. And this guy here did that. And, of course, you can pull out a 144. So their answer looked a lot more like this here. So there you go. Phew. Next one. 157029. It says find the mass and the center of mass bounded by a paraboloid, and they say z equals 8x squared plus 8y squared. We got a plane at z equals a, as long as a is greater than 0, apparently. And then it has a constant density of k. I think it's a capital K. I'm not 100%, I can't remember. But we'll be typing k for answers here later. So what is going on here? Well, first off, we got a paraboloid that's positive going up, kind of like this. And then it's cut off at a plane at A. So that's z equals A right there. Okay, and they're wanting to find the center of mass of this thing and the mass itself. Well, the mass is basically going to equal the volume, given that it's this constant density. Just toss a k in there and you're good. So my mass would then be triple integral k dv. Well, again, we've already seen this. K r dz dr d theta. Okay. The k can just come to the front. You don't really need that. So some things, notice that this right here would be 8r squared. And then notice that this plane is on the top while the paraboloid is on the bottom. And so when I start setting up my integral here, 0 to 2 pi, because we're going all the way around. I don't know about my radius yet. We'll fill that in here in a second. It's definitely 0 to something. And then my z, again, top and bottom, I'm going to have 8r squared is on the bottom, but a is on the top. Now, what goes right here? That's going to be kind of our question, dr d theta. So I want to know how much shadow it would have here on the xy plane. Well, notice that z equals this and z equals that, and so I got a is equal to 8r squared, essentially. I already know that's r squared, 8r squared, so it's equal to this guy. To solve for r, you divide by the 8 and square root, and so you get this really funny a over 8 square root thing. And so that's what I'm going to put in here. It's the square root of a over 8. Very strange, and it's going to be hard to decipher between the a and the 8s. I mean, it's just kind of so many circles going on, I suppose. Okay, so now just integrate. This shouldn't be too bad. So there's no z's. We're going to toss these guys down. Go ahead and keep this guy around a over 8. And so then we got an r times a minus 8r squared, dr d theta. Distribute your r. You can see you got r to the 1. Here you got r cubed. So when you integrate, you'll have ar squared over 2. And here 8r to the 4th over 4 from 0 to the square root business, d theta. The 0 will cancel everything. So when I toss this down, notice that the square and the square root will cancel. And you know that's going to be a 2 pi. Just go ahead and put 2 pi in there. So then we actually have a over 2 times a over 8. Okay. On this side, when you're tossing it in, it's the square root and a square will cancel, but you're left with another square. 8 and 4 will make a 2 in the front. And so you're squaring what was on the inside. Again, the 0 canceled and all that stuff. Well, here we got an a squared, and here we got an a squared as well. Remember that you have to distribute those guys. 2k pi, I guess. And then we're going to say a squared over 16. 64, and then cut 2 is going to be 32, so a squared over 32. 1/16 minus a 32nd is a 32nd, so we got 2 pi k a squared over 32, which makes the 2 will cancel there, pi k a squared over 16. So there's your mass, and that was one answer out of a lot. So here's a trick now, because we're needing to find the center of mass, right? Go back to your picture for just a second. It's kind of interesting. So we got a paraboloid, and then it's cut off by that plane there, basically, right? My planes are looking worse and worse. It's good enough. Okay, so we have this paraboloid. It's a cup. It looks like a cup, essentially. And it's centered at the origin, or I guess at least you can say the z-axis. And so it's kind of interesting. They're wanting x bar, y bar, z bar, right? Well, I can already tell you that the center of mass is going to be 0, 0 along this xy plane down here. Definitely 0, 0 right here in the middle, the origin, essentially. I'm just wondering where the center of mass is for the z. How high is it? Like, again, if this was all filled up, full of water, where would the center mass be? I think it's a little higher because, again, that has that bow shape and this has more of a cylinder at the top kind of thing. So I'm thinking a little bit higher than halfway up. So let's go and do the formula for it. Z bar is the same thing we just had. So let me go and start filling out. 0 to 2 pi, 0 to the a over square root, or square root of a over 8. Here we got the paraboloid, and it stops at the plane. And the only difference now is that you put a z in there. All the rest is the same. So r, dz, dr, d theta. Okay. And of course now we got to, and then divided by, sorry, almost forgot, divided by your previous answer for your mass. Okay, notice one thing. My mass here, I had a k technically here, but there's a k here, and therefore it's in the front, and then the k's cancel out, and da-da-da-da-da. You don't really need those k's. So, what I did is I tossed this to the top immediately. I said 16 over pi, and then a squared here in the bottom. I know that looks a little silly, but I think it'll be better in the end. Notice that we have a z this time, so when we integrate, it's going to be z squared over 2. So we actually have a 1/2 r, and then we're going to square each of the bottom and top that we get, dr d theta. What I did wrong, I did this problem and I got it wrong. I didn't know what was going on. I had squared the entire thing instead of squaring each individual item. Okay, so be careful with that. That's definitely a small mistake that can make the whole thing wrong. Lots of time was spent trying to figure out what I did wrong. That's okay. That's why I prepared for this stuff. So it's actually a little bit easier than if you had squared the whole darn thing. Distribute over here. I think we can pull the half out if you really want to. Not really required, I'd say. I'm going to distribute my r into here. So I got a squared r. And over here, I actually got 8 squared is 64. And then I have r to the fourth. And then one more makes r to the fifth. That's a lot of r's. D theta. Okay, hold on. My paper does not have an r sitting there. But then it does have it on the next part. So, okay. I mean, even with my notes, I still mess it up a little bit. The 16 and 2, you can make an 8 out of that. Again, we're just trying to keep it clean on the front if we can. That'll be 0 to 2 pi. Well, let's go ahead and integrate now. So r squared over 2. So a squared, r squared all over 2. And here it'll be r to the 6th over 6. From 0 to the square root of a over 8. D theta. This gets tossed into both places. Notice here, it'll cancel with your square root entirely. Making the original a over 8. Over here, you got it to the 6th power, and you got a square root. So you go ahead and you're going to cancel with 2 of them, and you're left with 3 essentially. You're taking 6 divided by 2 is 3 left over, so you're going to have a cube. You could also do this in the front just a tiny bit. That's 32 over 3. And so then we got a over 8 all cubed. And then the 0 would have canceled. D theta. You know that 2 pi, you can just go ahead and toss it in the front now, and it'll start to cancel stuff. Okay. So here we got an a cubed over 16. There we go. Over here, there's a big mess of stuff going on. So let me go ahead and use the calculator. 32 divided by 3. And then that stuff divided by 8 cubed. And math to frac. And I got 1 over 48. That is correct. So that's a cubed over 48. Okay. When you cancel your pi's out, your 2's make a 16. Here you got 16 minus a 48 is something. But they're both cubes, so you can pull the cube out. And essentially here we got 16 over a squared times a cubed times, well, just some kind of fraction. I would use the calculator for that one. Notice that your squares are going to cancel out right there. It actually all ends up being 2a over 3, so 2/3 a. Wow, all that for just 2/3 a. But that's the last one. So if you have any questions, let me know. Thank you very much. Have a great day.